Welcome in again, and this is our next video in our series talking about functions. Another topic this time. We're going to be talking about something called function overloading. Here we go. First, we're going to need a function, and I'm going to make sort of a modification of our star box, but I'm going to make just one little bar, let's say. So I'm going to come up here, and I'm going to call this void. I'm going to call it Starbar. I'm going to put an int in. So if I put in 5, it's going to give me 5 stars left to right, almost like a bar chart. So down here, if I say I want a star bar of size 5, then in my definition section, I'll come down here and I'll say int n, something like that. And I'll do for loop for int x equals 1, x goes up to and includes n. I'll print out a star, and then at the end of it, I will do end L. So very simple program. If you type in 5, it's going to go 1 to 5, print out stars left to right, and then end L at the end of it. Let me just give this a quick little spin, and as expected, there you go, 5. So we call it Starbar. What if you wanted something else? What if you wanted a bar of ampersands? What if you wanted a bar of exclamation marks? Something like that. Starbar might not be the best name for something. Let's just call it bar. So I'll just say bar. Change my name here. Make it generic. This is going to do the same thing. Just because we rename it doesn't make any difference. So let's have the default. We'll have the default be an asterisk. But like I said, what happens if you want something else? Well, it's not like you would want to really, make significant changes to this. Really, the only thing you're going to change is just right there. And that's kind of the key to this. The idea behind function overloading. I'll just put a little note here. Function overloading is having more than one function with the same name and purpose in your program, but the functions will have different parameters. When I say different parameters, it's going to vary in several different ways, and as you'll see here in a second. So what does all this mean? Well, I'm going to make another function prototype here. I still want int, but I'm also going to add in a second thing. I'm going to say char. So it's the same name, bar, bar. Both of them take an integer, but this one also takes a character. Let's say come down here and I say bar 10, comma, and then because it's a character, I want to put a single quote and an apostrophe, $sign. My purpose there is I would want a bar of 10 $signs. I'm going to take this code then, take my function, and I'm going to put on char, now let's just call it something like SYM for symbol. See, here's the key, is that what changes? I mean, the loop doesn't change, it's still 1 to n, but this, going back to what I said earlier, this changes. I don't want to pronounce star, I want to pronounce the symbol, that one tiny little change. Now I have the ability to call the function twice, one as a default, one as something more specific. So let's say I try this out now. So there I have 5 stars, there I have $10 signs. So I have two of the same name function. So right here, going back to my definition, more than one function with the same name. Boom, I already got that. It's the same purpose. They both make a bar. But the difference is you're adding just a little bit different. You have both that have the lengths, but the first one has a default, whereas this one doesn't. And you could do this with several different things. I mean, imagine you have a star box. You could have like a char box, where instead of a box of all asterisks, you would have a box of whatever you want. So lots of different possibilities with this. And the interesting thing is, going all the way back to the beginning of this chapter, there's user-defined functions, which is what we're doing here. We're making our own functions. But there's also the built-in functions. most all of those are overloaded, and I can easily prove it. If I say cout, what is the square root, for example? I don't know how well it's going to show up on the video, but you know, in your own program that hopefully you're coding alongside of me when I do this, you see here where sometimes when you type in a function, it pops up with like 1 of 4. So you see here it says like it's taking a double, it's returning a double. I don't know if you've ever tried this, but like try and click on these arrows. Square root can also take a float and return a float. Well, that's interesting because they're both square root. One takes a double, one takes a float. That's overloading a long double. This one, that it has something called a template, which we haven't even gotten into and we won't get into in this class. But like I said, there's lots more. If I do something like, what's the absolute value? This has 6 different overloads. It can take an integer, return an integer. It can take a long, return a long. It can take a long, long, and return a long, long. All kinds of different overloads with the built-in. So, you know, it would make sense that you could do the same thing for your own programs. For example, let's make a int square function. And I know this is going to seem silly. One of them takes an integer and returns an integer. The other one's going to take a double and return a double. So if I come down here and I say cout, what's the square of 5? It's going to give me 25. If I say what's the square of 5.0, that's going to give us 25.0, because if we code these as we state them, this one is an integer, this one is a double. The computer knows which signature to look for. If it's an integer, it knows to do the integer version. If it's a double, it knows to do the double version. So if I have int square, int x, return x times x, double square, double x, return x times x. That's a colon, not a semicolon. It looks the same. I mean, it's the same purpose. It's just the different variable types. And I know that doesn't seem like a big deal, but I mean, think about all the different times we've dealt with differences between integers and decimals so far. You know, just when you're doing division, whether you keep the decimal or whether you chop it off. And, you know, in doing so, it looks like they're both the number 25. I assure you they're not. You know, let's say I put in like 5.1 here. It's going to be pretty clear in this circumstance that you're going to get a decimal, 25 versus 26.01. And so, you know, it's those little subtle things that can make the difference between, oh, you have some kind of little typecast error, or, oh, it works fine. Not all of your math functions are built to work with every variable type. I don't know if you've tried this, but mod, I know mod's not really a function, but it's a symbol. If you try and do mod with a decimal, if I try like what's 4.3 mod 2.1, it's not going to like that. Mod is not meant to work for integers. And so those are little things to keep in mind. If I try and do like what's int x as the square root of 4, you know, square root of 4 is 2. What if I do something like square root of 5? You're going to be losing your decimal. Square root is supposed to return a double. You're storing it into something that it doesn't really fit into. So, like I said, it's these little types. We talked about C++ is a strongly typed language, meaning all the variable types matter. So, these little subtle differences can make or break the difference in your program. So, to wrap up, you know, what are and what aren't you allowed to do with this? Well, there are a couple rules. The overloaded functions may only differ in parameter types or numbers. So in other words, like if you have int versus int, there's 1 versus 2 parameters. You cannot overload a function simply by its return type. Okay, meaning you can't do something like this. You can't say int return to double, double return to double, because that violates the rule of functions. The rule of functions is one input, exactly one output. Talk to your Algebra 1 teacher about that. You can't differentiate solely by what's coming out because, again, the computer has no way of knowing which do you mean. You're sending in an integer, you're sending in a double, the computer doesn't know the difference when you're sending it back out. So you can't differentiate solely by the return type. But you can, as we said, by the number or type. So like here int versus double, type, and then here the count, int versus int and char. That is function overloading. It's going to come up more often when we get into object-oriented programming and classes coming up here in about a month or two. Just want to introduce it now. Thanks for watching.